log function. So the only thing you will be differentiating is the natural log of some function of x. Okay, and the only thing you're doing for natural log, okay, because these rules are about to do work for natural log. So, have a little sketch. So what does the y with the natural log of x curve look like?
Oh, natural log.
Or any log really?
That's like regression there.
Oh, it was close-ish.
What are the features?
Doesn't touch.
Doesn't touch the y.
Doesn't cross the y-axis. What else?
Levels out.
Yep. Decreases at a decreasing rate, and we'll talk about that when we do calculus. What else? Feature-wise.
Isn't it one?
Hey.
Crosses at 1 point.
Yep. Which is what b.
1.
Right. I'm going to draw the derivative function. What do you notice about the gradient of any point on that curve?
It's negative. No, not really. Positive.
Positive.
Always positive.
Always positive. Just while you redeemed yourself. Right, so if we get very close to the y-axis, the gradient is going to be very big, isn't it? Okay, so we're going to have some sort of thing happening along like this. As we get closer, we're going to start leveling out more and more to get something closer and closer to, but not 0. That is an estimation of the derivative function if you were to think about the gradient at that specific point. And that looks very strangely familiar. Hyperbola.
Oh, okay.
Yeah.
Thank you.
Robin McCullough's favourite thing at the moment. Okay, so if y equal to natural log of x, the first derivative is the hyperbola.
I don't want that.
And it's really cool. Yes, we can prove it. How are we going to prove it? How would you prove it? How would I prove it? Differentiation by first principles, okay? So, that's the rule. The derivative of the natural log of x is 1 on x, so the hyperbola in the first quadrant. So, y is equal to the natural log of some function of x. Okay, y dash is going to equal the derivative on top of the fraction of the function of x over the original function. Examples. Y equals the natural log of 2x, take away 3. So, when you have a log and you need to differentiate, y dash,
Because I'm short-sighted, I read it as a H, so I wrote it as a H.
I'm sure you're not the only person who's done that.
Don't worry about it. Did that too.
I'm talking about the general state and the history of HC. Matthew, you've probably done at some point too.
Did what?
Wrote the
LN as H.
No.
Whatever. Alright. So, on the bottom of the fraction goes the f of x, so what's after log, and on the top goes the derivative, so what's the derivative? 2. There you go, you just differentiated a log.
Happy birthday! It's Uncle Larry's birthday today.
Right. Next one is y is equal to 2, the natural log of 3x. Now again, you're only differentiating the natural log. Right, so you're not doing any other bases other than base e. Alright, y dash. So you've got the constant out the front. So I'm going to write it as the constant out the front. Times log of 3x. So fraction. The f of x goes on the bottom. And the derivative goes on top. 2 over x. So all your derivative functions for logs should represent hyperbola if it's just logs. Okay, and that's certainly what I've got so far. Alright, y is equal to the natural log of x squared. A couple of different things we can do. Alright, so y dash, fraction, f of x on the bottom, x squared, and what's the derivative? 2x. Okay, so we can simplify.
The connection.
Have you noticed it? Yeah, have you noticed it?
Yeah.
Wow.
Because that's the part.
Yeah, but this is the 3x.
Oh.
That's just an x. Pretty cool. What's the other way I can differentiate? Well, really, before I do that, what's another way I can write that?
2 elements.
2 times the natural log of x. Bring your power down, like we did with the exponential. Duh. Y dash is going to be 2 times log of x. 1 on x, which is 2 over x. Oh, there was a reason for that.
What?
There was a reason for that. Next. Alright, be careful. Y is equal to the natural log of x all squared. Note the difference.
I wonder.
Hey. Y dash is, how do I approach it? Boys? How do I approach this?
Expand.
So 2 log 2x.
What if I had y is equal to 2x plus 4 all to the power of 5? How would you differentiate that?
Function.
Function of a function.
1 to the minus 1 to go.
I can't remember the difference.
Differentiate.
You bring the 5 down and you times it by the...
Yep. So y dash, bring the 5 down, 2x plus 4, original function, 1 less to the power,
Times
and
it by 2.
Divide by, no, you divide.
You times it.
Times it by what?
Stop.
Times it by
2.
the derivative.
That's the one.
Okay? So, same approach. Plus 1 divided by derivative is integration. Alright, so bring the power down. The original function, decrease the power by 1 times by the derivative of inside the bracket. So 2 times the natural log of it, over x. Now that still forms part of a hyperbola, but you've got more asymptotes, more different things happening. Okay, and luckily we don't need to worry about that in this course anyway.
Hey, stop it. I just want to grab my pen.
Okay, y equals e to the negative x times the natural log of x. So what do I need to do here?
ln x to the e equal x.
ln x what? What's the rule that I need to use?
Oh, it's two different things.
F of x times g of x, isn't it?
F dash of x, g of x, plus f of
Yep.
x, g dash of x.
Okay, so you want to remember it that way? Alright,
Over some-
product rule. Second times the derivative of the first. So, what is the derivative of e to the negative x? We've done this at the start of the topic. So,
It's the same thing.
bring the derivative down, the power stays the same. Okay, so you bring the derivative down, power stays the same. Okay, so that's first times the second, times the derivative of the first plus the first times the derivative of the second. Okay, so e to the negative x times the derivative of log of x. Okay, so times 1 on x, so I'm dividing by x.
No, it's subtraction. Yeah, okay. It's division, it's subtraction.
Alright. Now we can tidy up, factorise, etc., but we're just working on differentiating skills. Right, y is equal to log base 2 of x. Now normally you would have to do differentiation by first principles, but you've learnt something today to be able to do something that you don't have to use that. Change the base. Alright, so y.
What is that?
Alright, so what base we're going to change it to?
E.
Log base e of the bit at the end over log base e of the original base. Right, so how am I going to differentiate that?
F dash of x, g of x, take away.
Ooh, really?
Is it?
So you're observing the quotient rule. So normally, yes, I would say that. However, what's in here that this doesn't have?
An x.
X. So that means this one is a constant number, isn't it? Log base e of 2 is going to give you a constant number. Right? So you don't have to do it that way. Yes, if you do it that way, you'll get the same answer. Okay, but you don't have to. So y dash 1 on the natural log of 2. So I've just, bad practice, log base e. I haven't changed the log again, I've just written it in this other way to write it. Times the derivative of this. Okay, because this is a constant, I've moved the constant right out the front, so you're left with log base e of x. So now I'm just differentiating that bit. So that 1 over x. Right, so it's 1 over x natural log of 2. Last one. Tangent and normal to the curve. Y is the natural log of 2x at the point where x equals 3. Okay, so I need you to write down, we need to work out, the equation of the tangent and the normal. To the curve y equals natural log of 2x at the point where x equals 3. So what's the first thing I need to do?
Find the y variable.
We can do that first, yep. So y is going to be the natural log of 3 times 2. Now they're irrational, these values, most of them, okay, so I'm just going to leave it as the exact form. Right, so now I've got a y value, x, y value. What else do I need to be able to substitute in point gradient formula?
Gradient.
The gradient, okay, and that's what the first derivative gives you. Y dash is going to be the f of x on the bottom and the derivative on top. Okay, so 1 on x. So, at x is equal to 3 specifically, y dash is going to be 1 on 3. Alright, so you've done this before. We're just incorporating now logarithms into this concept. Alright, y minus y1 is equal to m outside of x take away x1. So y minus the natural log of 6 is equal to a third outside of x take away 3.
You're nice.
Alright, so I like having y equals mx plus b because I can get more information from that more easily, and I can also make sure it matches this at the end. So y is going to be a third of x, take away a third of 1, and then I'm going to move that over to the right hand side. Right, so I'm just going to leave it in exact form because they hadn't told me to do any approximation whatsoever. Right, so that's the tangent. We now need to do the normal.
And 1 and 2 equals -1.
Right, so this times the gradient of the normal is equal to -1. So the perpendicular gradient, you simply flip it, change the sign. So it's going to be -3. Because a third times -3 is equal to -1. At the same point, so y take away the natural log of 6 is equal to -3 outside of x take away 3. Right, so y is equal to -3x plus 9 plus the natural log of 6. In y equals mx plus b form. Right. I'm not going to have time to get through all the integration, so I will do that tomorrow afternoon, and that'll be it. You have some chance to get some work done tomorrow. So I think we've done pretty well.
15 minutes.
10 minutes.